Hello guys, today we are going to discuss about mole fraction. What is mean by mole fraction? As you have heard the term about moles earlier, mole is the nothing but a unit which represents the amounts of atoms or molecules, or you can say elements. Suppose 1 mole of nitrogen mixed together with 3 moles of hydrogen gives 2 moles of ammonia, NH3. Okay, so today we shall discuss about mole fraction. What does mole fraction represents? What is the meaning of this term mole fraction? Today we shall discuss. Okay, so let us start. Before that, if you are new on my channel, then please subscribe my channel and press the bell icon so that you will get notification when I shall upload my new video. Okay, so let us begin. Now see what is meant by mole fraction. It is defined as ratio of number of moles of a component to the total number of moles of all component in the solution. Means it is a ratio of number of moles of any component divided by total number of moles of all the components. Okay, now let us take example. Suppose we have two components, component A and component B. So number of moles of component A is denoted by number of moles of component A is denoted by number of A. Okay, similarly number of moles of component B is denoted by number of NB. Okay, now see, according to definition of mole fraction, it is defined as ratio of a number of moles of a component to the total number of moles of all component in the solution. Okay, now if we are to find mole fraction of component A for this component A, then how we shall calculate mole fraction for component A? So now see, the mole fraction of any component is denoted by xi, this symbol xi. Okay, so since we have to find mole fraction for component A, so we shall write here xi A, means we are finding mole fraction of component A. Okay, so xi A means mole fraction of component A equal to, we have to find mole fraction of component A. So according to definition of mole fraction, ratio of number of moles of a component. So of a component means we are finding the mole fraction of component A. So we shall write in the above Na, number of moles of component A, because we are finding mole fraction of component A. So number of moles of component A we have to write in above. Now see, to the total number of moles of all component. So in the denominator we have to write the number of moles of total components. So here two components is there, and number of moles of these two components is Na plus Nb. Okay, so this is the mole fraction of component A. Similarly, if we ask to find mole fraction of component B, then how we shall write? So mole fraction of component B means xi B equal to, in the numerator we have to write Nb, because we are finding the mole fraction of component B. So number of moles of component B we have to write in the above. Okay, so divided by total number of moles of all components. Here also two components is there, so we have to write here Na plus Nb. So this is the mole fraction of component B and this is the mole fraction of component A. Okay. Now again suppose if we have 3 components or 4 components and we are to find the mole fraction of any component, then how we shall find? So let us, we have 3 components A, B and C. We have 3 components. So number of moles of component A is denoted by Na, number of moles of component B is denoted by Nb, and number of moles of component C is denoted by Nc. Okay. So now we are to find the mole fraction of component A. So how we shall find? So mole fraction of component A is denoted by xi A. Okay. So equal to, in the above means in the numerator we have to write Na because we are finding the mole fraction of component A divided by total number of moles of all components. Here 3 components is there, so we have to write here Na plus Nb plus Nc because total number of moles of all components. We have to write here all number of moles of all components. Here 3 components is there, so we have to write 3 components here. Okay. Similarly, if we are asked to find the mole fraction of component B, then how we shall find? Mole fraction of component B is denoted by xi B. So equal to, here we have to write Nb because we are finding the mole fraction of component B. So in the denominator we have to write total number of moles of all components, Nb plus Nc. Okay. Similarly, mole fraction of component C is denoted by xi C equal to, here we have to write Nc because we are finding the mole fraction of component C. So divided by Na plus Nb plus Nc. Okay. So this is how mole fraction can be calculated. Okay. Now you can see here another interesting thing. The sum of this mole fraction means the mole fraction of component A and mole fraction of component B means xi A plus xi B is equal to 1. Xi A plus xi B is equal to 1. How? I am showing you. So xi A plus xi B equal to, what is the value of xi A? This is the value of xi A, Na by Na plus Nb, and what is the value of xi B? Nb plus Na plus Nb. Okay. So if we take LCM, then what will be the LCM? Na plus Nb. Okay. Nb. So here also Na plus Nb. Now if we cut this, then result will be 1. Okay. So xi A plus xi B equal to 1. Similarly, in this case also xi A plus xi B plus xi C will be 1. Okay. I think mole fraction is clear. So see you on my next video. Thank you for watching.